All right, in this video, we're going to think of a large multi-digit number. We'll think of 3,897,423. Now, I did this on purpose where I had two different threes in here. Those threes have the same face value, but different place value. So that helps us differentiate. The 3 farthest to the left is 3 million, or 3 times 10 to the 6th power. Or in other words, 10, groups of 10, groups of 10, groups of 10, groups of 10. Say that 5 times fast. Whereas the 3 at the end is just 3 ones. So they have different place values, but the same face value. Now we're going to focus in on this 7. It has a face value of 7, but its place value is 7,000. Or in other words, 7 groups of 1,000. I guess I should point out I always cross my 7s. It's not something you have to do. In fact, it probably isn't good to do in an elementary situation. It's just a habit for writing 7s on a whiteboard to make them more clear. Let's talk about that 7,000, the different ways we can think of it. 7 times 1,000 is the same as 70 groups of 100. But that's also the same as 700 groups of 10, or 700 ones. These are all correct ways, or excuse me, 7,000 ones. These are all correct ways to interpret that place value as 7 1,000s, 70 hundreds, 700 tens, and 7,000 ones. You may wonder, why do we care that I can represent this in all these different ways? Well, you'll use that when you're regrouping in addition and subtraction. I need to know that 7 1,000s is the same as 70 100s if I want to regroup that or subtract a group of 100s from it. Let me give you a couple other ways of representing this. I can also think of 7 times 1,000 as 7 tenths of 10,000, or 7 100ths of 100,000. This is important to recognize that this place value is a group of 10 of place values to the right, and one piece of 10 needed to make the place value to its left. This is actually one of our Common Core state standards, also which were adapted into the Utah state standards. If you're not familiar with them, the Utah state standards are a list of pieces of knowledge we expect students to gain as part of different grades. So here are standards I went through and found that have to do with counting in base 10. You may notice how in kindergarten we talk about counting in cardinality. In first grade, we talk about what the 2 digits mean. Second grade, we go to 3 digits. Third grade, we use that to round. In fourth grade, we recognize that in any length whole number, a digit in one place represents 10 times what it represents to the right. In fifth grade, we expand that to say it's 1/10 of what it represents to its left. These pieces of information are all necessary for you to know as a teacher so that you can teach whatever grade you come across. See you in class.